Okay, in this lesson, we are going to review graphing proportional relationships. So within this lesson, we're also going to review direct variation. So what does it mean for two things to be proportional? So let's review from last year. Well, in order for two things to be proportional, the two rates have to be equivalent or equal to each other. How can we tell if two ratios are proportional? Well, there's three different methods that you can use. One of them is that you could check the cross products property. So for example, if we had 2/3 and 9/12, we could check cross products. Okay, so 12 times 2 is 24, 3 times 9 is 27. Are those two equal to each other? That would be no, so therefore they would not be proportional. Okay, we could check to see if the ratios convert to equivalent fractions, so we could change each fraction. So like here, since I already had a denominator of 12, I could leave that as 9/12. I could take 3 times 4, and 2 times 4 would give me 8/12. And we could compare those two fractions. They are not the same fraction, so once again, it proves that they are not equivalent. The last step is we could take our original fractions of 2/3 and 9/12, and we could convert them into their decimal. So 2 divided by 3 would give us 0.67. And 9 divided by 12 would give us 0.75. So once again, we notice that the decimals are not equivalent to each other or equal to each other. So those are the three different methods. Probably the one that we used the most last year was the cross products method. Okay, and if you get the same answer for both situations, then they would be considered proportional. We also worked a little bit with direct variation. So let's review really quickly what direct variation is. It's when an equation can be written in the form of y equals kx, where k is a constant number, so just a standard number. And if it's graphed, when you see the graph, it will pass through 0, 0. So those are the key things that we're going to kind of be reviewing in this chapter. Okay, so our activity, this is within your practice journal. We're going to tell whether x and y are in a proportional relationship. So in order for that to happen, they have to be proportional. We can check cross products, so we can grab coordinates off of there and check the cross products of those. And they also have to pass through 0, 0. So they have to meet both of those qualifications. So if we look at letter A, well, it does meet the qualification of passing through 0, 0. So now we're going to go through and check to see if they're proportional to each other. So I'm going to pick up 2 points on this line and just check their proportion. So I'm going to do my x over my y. Okay, so let's see. My x was 1, my y was 10. So 1 to 10. And then for my other dot, we'll just take the next point up that's on a crossing bar or right on a corner. The x was 2, the y was 20. Okay, so we could either reduce and get equivalent fractions, we could check cross products, or we could do decimals. I like to do cross products because I'm faster at multiplying in my head. 20 times 1 would give me 20. 10 times 2 would give me 20. Are those equal to each other? Yes, so this would be proportional. They do meet the satisfaction of being in a direct variation. Okay, so let's go ahead and try another one. Let's go ahead and look at letter B. So here we have another graph. It has to meet both qualifications, so it has to be in a proportional relationship. It also has to pass through 0, 0. So the fastest one to check when you're seeing a graph is to check this 0, 0. Is it crossing through 0, 0? No, so it's already eliminated based on that. But we'll go ahead and check the cross products also. So I'll pick two parts. I'll pick 2 points. Let's do this one just because they're pretty small numbers to multiply. And we'll do that one. So it looks like we had for our x, 6, and our y was 5. And on my second point, which I'll change to blue, it was 5 and 10 for my y. So if I check cross products, 25, 60, those are not even close to being equal to each other. So this one would be not proportional. Okay, but we were also able to eliminate based on the fact that it did not cross through 0, 0. All right, we're going to try one without a graph. So some of you may decide you would rather see this in graph form, and that's perfectly fine. I'm going to go ahead and work with you on how you could check it without having to plot it on a graph. If this is something that you want to plot on a graph, you can go ahead and do that, but you'll have to set up the graph yourself. So the first thing I would want to see, well, I can't really see if it crosses 0, 0. They've really only given me 4 scenarios for my cups of sugar and my cups of flour. So I would have to work my way backwards to see if I worked backwards following a sequence, if I would end up with a 0, 0 as my next set or my very first set of coordinates. Okay, so when you're doing these are set up as our X's and our Y's. So if you graphed it and you drew your line, you could maybe see if it crosses through 0, 0. I don't want to take the time to graph it. So I'm going to go ahead and kind of look to see what's happening between each of my points. So if I went from 2 back to 1.5, that would be subtracting a half. 1.5 back to 1 would be subtracting a half. So there's my pattern. I'm subtracting a half each time. So a half minus a half would give me 0. Okay. So if I were to go backwards, I would have another set of 0 there. So let's check this pattern. 4 minus 1 would give me 3. 3 minus 1 would give me 2. 2 minus 1 would give me 1. So if I subtract 1 again, that would give me 0. So it looks like it's meeting the qualification of passing through 0, 0. Now I have to check to see if they're proportional. One thing is they do follow a pattern. So that makes sense, but we'll go ahead and check like we did on the previous ones. We'll take an X and a Y, 2 sets, and we'll kind of check cross products. And you could pick really any 2. So I could pick these first 2, but maybe I'm not really comfortable with multiplying by fractions. I could change them to decimals. I could also do this. I'm going to pull this one out and this one because I'm really good with whole numbers. So 1 over 2, and these were my X's and my Y's, and then 2 over 4. And I'm going to check cross products here. 1 times 4 is 4. 2 times 2 is 4. Were those equivalent to each other? Yes. So letter F would also be a proportional relationship. Okay, so go ahead and pause your video. Work your way through the rest of the other 3 that are there, checking to see if they're proportional. So key thing is they have to pass through 0, 0. So if it does not pass through 0, 0, it's already eliminated. You also have to have proportional relationships or equivalent fractions to one another. So good luck with the rest of this.